In the space of science and massive secrets, the subject of what existed already, the enormous blast, has sparked mixed discussions and captivated thinkers for a long time. This tremendous question doesn't simply test how we could translate the universe. It challenges the utmost spans of human knowledge. Imagine standing at the edge of existence, exploring the vast darkness, and pondering what lay there before our universe was conceived. The event of the Big Bang marked the dawn of humanity, space, and everything we know. But was there a moment before that? Could there have been a state of nothingness, a calm before the cosmic gathering began? And if this is true, what was it? Or perhaps there was something even more mysterious that existed before time itself. As we dive deeper into this question, science takes us on a journey beyond the universe's starting point into ideas that challenge our awareness. Physicist Brian Cox, known for his research into the wonders of the universe, suggests that something extraordinary might have existed before the Big Bang. He invites us to rethink our understanding of reality and existence. In this exploration, we'll examine the science, the theories, and the astonishing secrets that might explain what existed before it all began. We'll explore ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astound you, but they could also provide new insights into our place in the universe. Prepare to dive deep into a world beyond imagination and science, where darkness still weaves through the shadows, leaving researchers awestruck and sometimes even frustrated. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. The Big Bang. Understanding the beginning. To appreciate what might have existed before the Big Bang, we first need to carefully analyze what the Big Bang actually was. The Big Bang, as defined by scientists, refers to the moment when the universe became incredibly hot and dense, rapidly expanding to kickstart the formation of all matter, energy, and forces. When we gaze at the night sky, we see evidence of this fiery beginning, with galaxies spreading out from an initial point. But why did this happen? Moreover, was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there indeed was something before, and it was far from empty or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and free, essentially like a vast vacuum. However, this vacuum wasn't entirely empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. The theory of multiverses. This expansion, known as inflation, occurred so quickly that it essentially laid the groundwork for everything that followed. Space expanded at unimaginable rates until the inflation slowed, and the energy transformed into matter, particles, and forces. The Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe? And why did it stop? Experts believe this cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This concept, called the inflationary multiverse, suggests there could be countless Big Bangs and an infinite number of universes. Ours is just one among many. This mind-bending reality challenges our understanding of the universe itself and leaves us questioning, what else is out there? The idea of nothingness. The notion of nothingness before the Big Bang is speculative, yet intriguing. Per our current understanding, even if you removed all energy, particles, and radiation from the universe, it still wouldn't be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create a complex cosmic fabric. Even in its most vacant state, space would still generate new forms of energy. This fact alone confounds experts, as it suggests that true nothingness might be impossible within our infinite understanding. Space itself has properties, rules, and constants that prevent it from being completely empty. Even when stripped of everything, quantum fields and fundamental constants would still exist, indicating that this nothingness has properties. For example, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and vanish, creating a faint echo of activity even in what should be empty space. This challenges our concept of a true void and suggests that, yes, even before the Big Bang, there was something scientists are only beginning to understand. The immortal multiverse. One of the most fascinating theories in modern cosmology is the possibility of eternal inflation. If inflation could create our universe, it's possible it could continue forever. Brian Cox describes an unimaginably vast inflationary multiverse, where universes are endlessly created and continue expanding. Imagine each Big Bang as a spark igniting another universe, while inflation continues in other regions, creating countless universes. This process could, in theory, happen forever. This idea of infinite universes gives rise to the concept of a fractal universe, where each new universe might create its own Big Bang. Each universe exists as a separate, independent region, unaffected by others, due to the rapid expansion of space. For researchers, this theory is both exciting and unsettling, as it suggests a perpetual multiverse with no definite beginning or end. Quantum field theory, the foundation of somethingness. Our understanding of the universe further evolves when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space, but rather an intricate network of energy fields that permeate everything. These fields are like invisible oceans, with particles acting as waves or disturbances within them. Even when fields are at their lowest energy state, known as the vacuum state, they remain active. Particles can appear and disappear within these fields, momentarily borrowing energy before returning it. This phenomenon gives rise to virtual particles, fleeting entities that exist for a brief moment and then vanish, leaving behind subtle traces. The concept of virtual particles challenges the idea of absolute emptiness. Even in an empty universe, stripped of all matter, radiation, and energy, quantum fields would still be active. Occasionally, they would create transient particles, hinting at a hidden layer of reality where nothingness is more dynamic and structured than it seems. This raises an intriguing question. If quantum fields can create particles and particles can form matter, could the universe itself have emerged from this state of quantum nothingness? Dark energy, a force from before the Big Bang? Dark energy, the mysterious force driving the accelerated expansion of our universe, might hold clues to what existed before the Big Bang. Some theories suggest that dark energy could be a remnant of an energy field predating our universe's formation. Dark energy accounts for about 68% of the universe's total energy, yet its origins remain elusive. Its role in the cosmos today might provide insights into the conditions before the Big Bang. Could this enigmatic force be a relic of a previous cosmic state, one that transcended the known dimensions of time and space? If so, it implies that the universe is not an isolated event, but part of a larger, ongoing process governed by forces beyond our comprehension. Timelessness and eternal creation. The most mind-bending theories challenge even the concept of time. Some cosmologists propose that time itself might not have existed before the Big Bang. Instead, what we perceive as the beginning could be just one phase in an eternal cycle of creation and destruction. For instance, the cyclic universe theory suggests that the universe undergoes infinite cycles of expansion and contraction. Each Big Bang is followed by a big crunch, which then leads to another Big Bang. In this view, time is not linear, but circular, with no definitive starting point or end. Alternatively, some models of the multiverse propose that time is an emergent property, arising only within individual universes. Outside these realms, there is no before or after, only a timeless expanse where universes bubble into existence. The limits of human understanding. While these theories stretch the boundaries of science, they also highlight the limits of human understanding. The questions surrounding what existed before the Big Bang push against the edges of physics, philosophy, and metaphysics. Philosophical implications. If the universe arose from nothingness, what does that say about existence itself? Can something truly emerge from nothing, or does nothing have properties we've yet to comprehend? Scientific challenges. Testing these theories is incredibly difficult, as they involve conditions and events beyond the reach of current experiments and observations. Emotional impact. For many, the idea of a multiverse or an eternal cycle of creation is both awe-inspiring and unsettling, as it redefines humanity's place in the cosmos. Energy appears to propose a Goliath, stowed-away force that could have existed in some form before the Big Bang. Some speculation suggests that dark energy, in a much stronger state, might have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that, even if our universe were depleted of all matter and radiation, this force would continue to expand the fabric of space-time. This idea leads to a disturbing question. If dark energy was present before the Big Bang, could it have formed the conditions that led to the birth of our universe? Could dark energy be the silent architect of expansion, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not merely as a force shaping our universe, but as a key that could unlock the mysteries of the multiverse itself. Another hypothesis that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe goes through vast cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event, but part of an eternal rhythm where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe could have been reborn from the remnants of a previous universe. The cycle of contraction and expansion in a cyclic pattern would imply that there was never a true beginning, but rather a timeless series of universes arising, evolving, and renewing themselves endlessly. Cyclic cosmology raises profound questions about time, proposing that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this hypothesis offers a compelling answer to the question of ultimate origins, suggesting that there is no definitive beginning. The universe has always existed in some form, transcending our concepts of time and existence. Early-stage gravitational waves are another fascinating idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe that early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as echoes of what preceded the Big Bang. If detected, they could provide evidence of the universe's past states. The potential discovery of early-stage gravitational waves would be a groundbreaking leap in our understanding of the universe's origins. These waves could carry information about the conditions that existed before the Big Bang, offering a glimpse into the fabric of space-time itself. If we can detect these waves, they might reveal evidence of energy fluctuations, quantum states, and other phenomena that predated the formation of our current universe. The detection of such waves would provide the first direct observational evidence of events occurring in the extraordinarily brief time after the Big Bang, during the inflationary period. Since these waves are hypothesized to have been produced during the rapid expansion of the early universe, finding them would confirm many predictions made by cosmological models. This discovery could potentially answer some of the deepest questions about the nature of time, space, and the universe itself. Understanding these gravitational waves could also help us explore the concept of eternal inflation. This theory suggests that while our observable universe began with the Big Bang, the process of inflation continues in regions far beyond our reach, giving rise to an infinite number of parallel universes, or pocket universes, each with its own distinct properties. These universes might follow different physical laws or have unique dimensions, and the discovery of gravitational waves could provide indirect evidence of their existence. In the grand scheme of things, such discoveries would underscore a far greater realization. The boundaries of our universe are far more fluid and expansive than we ever imagined. We may begin to see our universe as just one chapter in an infinite saga of creation and destruction, an eternal cycle of birth, death, and rebirth, where each universe follows its own path, shaped by factors we are only beginning to understand. As we delve deeper into these speculative realms, we must also consider the philosophical implications of pondering what came before the Big Bang. Could our conventional understanding of time, space, and causality be inadequate to explain the nature of the universe? Some theories even propose that time itself might not have had a clear beginning. Perhaps time, like space, is a property that came into being only with the creation of the universe. Before that, there may have been no before, an idea that is meaningless outside the framework. As humanity seeks to understand this notion challenges everything we know about reality, we inevitably face questions that consider beyond the realm in ways that stretch our imagination and into the philosophical. The idea of no beginning. These questions challenge us to reconsider the number of universes existing simultaneously, and even our own pushes the limits of human understanding. Could the universe? We may find that our traditional definitions of reality, incomprehensible of what it means to exist, might there exist no other dimensions in the universes such astounding or even states of reality. In conclusion, what our the mystery of what existed before the Big Bang is more than just one of the most intriguing possibilities. It is a profound question that touches on the very nature of reality itself. A collection we are talking about a pre-Big Bang, each with its own laws of physics, the existence of quantum fields, and dimensions, or the possibility this of idea is supported by theories. These ideas challenge our most fundamental assumptions about time, which suggest that multiple universes could coexist. While we may never fully understand what came before the Big Bang or dimensions, the journey to answer this question, if true, the multiverse would fundamentally change our understanding of existence. The more we uncover about the origins in a multiverse, the more we realize that our understanding as one of countless others, still each arising from different initial conditions, and the quest for answers will continue. This raises expanding the horizons of human knowledge. Why does our universe unlocking have new doors to the mysteries of the universe? Is our universe fine-tuned for life? Or is life simply a consequence of the particular laws and constants here? If there are infinitely many universes, might some even harbor entirely different forms of intelligence or consciousness, unrecognizable to us? The search for answers also brings us to the frontiers of quantum mechanics and its implications for the nature of reality. Quantum phenomena, such as entanglement and superposition, suggest that the universe operates on principles that defy classical logic. Could these principles hold the key to understanding what existed before the Big Bang? Some physicists propose that the universe emerged from a quantum state where the classical concepts of time and space did not exist. Instead, the universe might have been a timeless quantum foam, out of which space-time emerged during the Big Bang. Moreover, the quest to understand the origins of the universe intersects with humanity's age-old search for meaning. If time and space themselves are properties of the universe, then the concept of before may not apply in any conventional sense. This raises philosophical questions about causality. If there was no before, then what caused the universe to come into existence? Is it possible that causality itself is an emergent property, arising only within our universe's space-time framework? The implications of these ideas are profound, not only for science, but also for our understanding of ourselves. If our universe is just one of many, or if time itself is cyclical, then the story of our existence becomes part of a much larger, eternal narrative. This challenges anthropocentric views of humanity's importance and forces us to confront the possibility that we are a small piece of an infinite puzzle. In the end, the search for what existed before the Big Bang is more than a scientific endeavor. It is a journey into the deepest questions of existence. It compels us to push the boundaries of our knowledge and imagination, to explore realms of thought that transcend our current understanding. While the answers may remain elusive, the pursuit itself enriches our understanding of the universe and our place within it. As we continue to probe the mysteries of the cosmos, new discoveries may reshape our understanding in ways we cannot yet imagine. The universe, with all its complexity and wonder, serves as a reminder of the limitless potential of human curiosity and the enduring quest to unravel the secrets of existence. Whether the answers lie in the nature of dark energy, the properties of gravitational waves, or the structure of the multiverse, one thing is certain. The journey is as important as the destination, and the pursuit of these questions will continue to inspire generations to come.